And we're back. So, yesterday, I asked you if you saw a pattern in those three examples. Okay? So, to refresh your memory about those three examples, here is example number 1 and example number 2. And then if I slide it on down, we'll see example number 3. Okay? So specifically what I want you to look at is I specifically want you to look at theta, or the point that theta goes through, I should say, and the sine, the tangent, and the cosine. Do you guys see anything, any pattern developing there? See if we see a pattern, and then we'll verify it on example number 3. Because there is one. What do you got, Jack?
The tangent is always positive.
Tangent's negative in number 1. Work that through one more time for me. Okay, so what you're saying here is, now I got to get off of the highlighter, back to the pen. So you're saying that, oops, I can't use that color. I didn't use purple. So you're saying that this -5 right there showed up as cosine right there? Okay. But actual -5 showed up there too, right? Yeah. Okay. All right. Emily? No. Close though. Good.
If the x is negative, then the cosine's negative.
Okay. That's one pattern. Okay, that's kind of what you guys were both saying back there, yeah? More importantly, and we'll verify this here on this next one, okay? In general, if theta is through x comma y, okay, and r is the square root of x squared plus y squared, because that's Pythagorean theorem to find that hypotenuse, right? That's the first thing that we did yesterday on all of these. We found the hypotenuse there first, then we found the hypotenuse there first, then we found the hypotenuse there first, right? Okay? And we use Pythagorean theorem to do that. If that's what we're going to do, then the sine of theta is y over r. Think about the unit circle for a minute. What is sine of theta on the unit circle? In a unit circle coordinate, what's sine? It's y, right? Okay. What's the radius of the unit circle? 1. So it's y over 1. Okay. So that even holds on the unit circle. What do you think cosine then is going to be? What? X over r. Tangent. Y over x. Cosecant. What? R over y. Secant. Cotangent. Right? Okay. Now, to find the reference angle, you're going to use finding an angle. So we're going to use an inverse, and that inverse is going to be tangent. Why do we use tangent as our inverse? Because we don't have to do any extra figuring. It uses the parts of the point, the two parts of the point. Okay? Now, yesterday I told you that you could use any of those three. Because we found the sine, we found the cosine, we found the tangent. You could use the inverse any of those three. And that's true. You just got to do extra figuring if you're actually going to use sine or cosine. You got to use the Pythagorean theorem and find that R value. Okay? The kicker is, because this is our reference angle, X and Y are both positive. Okay? Because we're using it as our reference angle. So we don't use, like in that first example we did yesterday, we wouldn't use -5 there. We'd use +5. Absolute value of that, if you will. Okay? Right? And that finds you the reference angle. Okay? So let's verify that now here on example number 3. Here's the point that it went through. Theta is through 8, -15. So without doing any work, my tangent should be -15/8. And it is. Okay? Using the Pythagorean theorem, 8 squared plus 15 squared, or -15 squared really, gets me, and then I take the square root of that, gets me 17. So then my sine would be -15/17. My cosine would be 8/17. Okay? And then I could use the inverse tangent to find my reference angle. This reference angle is going to be in quadrant 4, so I would subtract it from 360 degrees. Okay? So that's the pattern from yesterday. Today, what I would like to accomplish is I would like to accomplish those last 3 question type problems on the worksheet. Yes, those type of problems. Okay? So I don't believe that this is one of them. Nope, it's not. Okay? But the question says, find the cosine of theta, the tangent of theta, and theta if the sine of theta is 3/5 and the secant of theta is positive. Okay? So we are given 2 conditions. And the reason that we're given 2 conditions is because if I was just given the first one, sine of theta is 3/5, that would leave me in 2 different quadrants. Okay? Sine is positive up here in quadrant 1 and quadrant 2. Well, I can't narrow down where theta is if I'm sitting in 2 different quadrants. So this tells me that I'm in quadrant 1 or quadrant 2.
Wait, did you say these are examples on the homework or no?
They're like the ones. They're not on the homework.
Got it.
Okay? All right? Secant is greater than 0. Well, secant is attached to what? Sines or cosines or tangents? It's attached to cosines. Okay? So this is like saying that the cosine of theta is greater than 0. Where is the cosine of theta greater than 0? first quadrant or the fourth quadrant is where cosine is greater than 0. Okay? So which quadrant is my theta in? I'm in quadrant 1 because quadrant 1 is the only one that shows up in both of my conditions. Okay? Oops, I wouldn't even need that. Instantly regret. So now that I know that theta is in quadrant number 1, my triangle is going to look like that, correct? Where this is the origin, which means then that do I have a reference angle here? It is, right, exactly. Theta is my reference angle, so that's going to save me a step on the tail end. Okay, so there's theta, or theta prime, whichever one you want, in this case. Sine is 3/5. What is sine? Opposite over hypotenuse. Okay. Do we know what that missing side is yet? 4? Okay. So, what is the cosine of theta? Four-fifths? Done. What is the tangent of theta? What do you got? 3/4? Done. Now we just got to find theta itself. So to find theta itself, I would say that theta here is equal to, I'm going to go with the inverse sine because it's given to us. Right? Okay, sine was given to us, so let's use that one. So what is the inverse sine? If you wanted to use inverse cosine, if you wanted to use inverse tangent, that would be just fine. What do we got there? You can give it to me in radians or degrees, I don't care. In radians, that would be 0.644. And there's my 3 answers, depending on which one we say. Directions are going to be very important for you because it's going to say, give your answer in radians or give your answer in degrees. Okay? Handle? All right? What I would like you to do now is I would like you to try this one. So this tells me that I am in quadrant 2 or 3. Right? Because that's where cosine is negative. Left side of my unit circle. Tangent being positive tells me that I'm in quadrant 1 or 3. Right? So my theta is going to end up in quadrant 3.
Okay, wait, the only reason you get rid of quadrant 1 being an option is because it doesn't go with cosine being negative? That's
Correct.
Okay.
Same way I can get rid of quadrant 2 because tangent's negative in quadrant 2.
Correct.
Yep. It's got to fit both conditions in order to narrow it down to which quadrant it's in. Okay. So my triangle is going to look like this, and I like to draw my triangle in that orientation. So this is my theta prime. Cosine is adjacent over hypotenuse. So this is 5 and this is 13, which then makes this side be 12 if I use Pythagorean's theorem. Okay? So the sine of theta prime, oops, that's not blue. That's blue. So the sine of theta prime, my reference angle, is going to be 12 over 13. Agree with me on that? But in quadrant 3, sine is negative. So the sine of theta is negative 12 thirteenths. Okay? Cotangent of my reference angle is adjacent over opposite 5/12. Cotangent in quadrant 3 is positive, so that's going to stay the same. Now we just got to find theta. Okay? So my reference angle is going to be, let's use, since we had the cosine before, we'll use inverse cosine, or you can use whatever you want. I'm totally cool with that. 5 over 13. Okay? So that's going to give me a reference angle of 67.380 degrees, or 1.176 radians. Right? But now I'm in quadrant 3, correct? So theta in quadrant 3 would be 180 degrees plus my reference angle, or it would be pi plus my reference angle, because I'm in quadrant 3. So actual theta is going to be 247.38 degrees, or 4.318 radians. Questions on that one? Speak now if you got something wrong or confused about something. Yes, ma'am. Well, you need to have the reference angle, like, like these blue ones? You can go right to it. It provided you know what's positive and what. Yep. And in fact, on mine, tough to see this on the video, but on mine I went right to it also. Yep. I didn't go right to it because I needed to find my reference angle. Okay. But on that one, I definitely have to show this orange work. You have to show. Okay. But the blue you can skip over. Yep. I just did that for the benefit of some people in the room. Okay.
circle to see where actual theta would fall? If you were to like rest it.
One more. Try it. So secant goes with cosine, right? And a positive cosine happens in quadrants 1 or 4. Negative sine happens in quadrants 3 or 4. So I'm in quadrant 4. So secant of theta is cosine, so that would be a 2 there and a 5 there. Okay? Secant is hypotenuse over adjacent, so 5 for the hypotenuse, 2 for that. Do some figuring, some little Pythagorean action going on over here. Tells me that 5 squared equals 2 squared plus x squared. 25 equals 4 plus x squared. So 21 is x squared. So this side here is the square root of 21. Okay? So that tells me then that I needed the cosine here of theta. So the cosine of my reference angle is going to be 2/5, okay? Which is going to be the cosine of my actual theta, because in quadrant number 4, cosine is positive. Okay? And again, if you wanted to skip right to it, that's totally fine with me. Okay? I needed the cosecant. So the cosecant of theta prime, or of my reference angle, is going to be the hypotenuse over the opposite side, which is the square root of 21. But cosecant is attached to sine, correct? So in quadrant 4, that's negative. So the cosecant here of actual theta is going to be negative 5 times the square root of 21 over 21.
How do you get the, why do you do the hypotenuse over the?
Because it's cosecant. Cosecant is the reciprocal of sine, right? And sine is opposite over hypotenuse.
Oh, okay.
So cosecant would be hypotenuse
Okay.
over opposite.
Yeah.
Okay? Then I need to find my theta prime. So I would go with the inverse cosine here of 2/5. And that's going to be 66.422 degrees, or 1.159 radians. But because I am in quadrant number 4, actual theta is going to be 360 degrees minus my reference angle, or 2 pi minus my reference angle. So theta here, whoa, tap the brakes. So theta here is going to be 293.58 degrees, or theta here is going to be 5.124 radians. Yeah, buddy? Yeah, buddy. Have yourselves a great, grand, and wonderful Thursday. They will be now.